So now that we've talked about the basic structure of carbohydrates, and particularly monosaccharides, I'm going to just take a couple of slides and talk about the chemical properties that are present in a subset of monosaccharides. So we're going to talk a little bit about what we refer to as reducing sugars, and that's going to require you to remind yourself a little bit about what oxidation and reduction reactions entail. So remember that oxidation and reduction go hand in hand. For oxidation to occur with one molecule, another molecule has to be reduced, and that's going to go both ways. For there to be reduction of a molecule, there has to be the oxidation of another substance. So a reducing sugar is going to be defined as a sugar that allows the reduction of another substance. So it is reducing another substance. And by doing that, the reducing sugar itself is oxidized. Now we'll talk about this in detail, but don't let the terminology frustrate you too much. A reducing sugar is reducing another substance. And if another substance is being reduced, then something has to be oxidized. And the sugar itself is what is oxidized. So reducing sugars are monosaccharides that contain a carbonyl group. Remember, the carbonyl group is C double bond O, that oxidizes to give a carboxylic acid. So we're going to look at that on this slide. Right here we have glucose. Remember, glucose is right at carbon 2, left at carbon 3, and then right at carbons 4 and 5. So right, left, right. So this is glucose. Glucose is an aldose, so the C double bond O at carbon 1. Now remember, back in the organic chemistry section we talked about oxidation of aldehydes, and that when we have oxidation of aldehydes we get a carboxylic acid. So what is happening with a reducing sugar is that the carbonyl group, the C double bond O, is being oxidized to form a carboxyl group. So the C double bond O with an additional OH. So that makes this portion of the molecule the same functional group as a carboxylic acid. So the glucose is now no longer referred to as D-glucose, but we're going to change the suffix OSE to onic acid. So this is D-gluconic acid. And again, that's because we've replaced the hydrogen with the hydroxyl group, the OH. At the same time that we are oxidizing carbon 1 of our glucose molecule, we are reducing copper ions. So oxidation is occurring here, and reduction is occurring here. So to test for this, we can use what we call the Benedict's reagent. Again, that's going to be copper, and the copper that is reduced is going to allow the carbon 1 to be oxidized to a carboxylic acid. So the monosaccharides that can serve as reducing sugars are glucose, galactose. Remember that the galactose is the same as glucose except it differs at carbon 4, and also fructose. Now fructose itself is a ketose, but it can be oxidized because fructose can easily be converted into glucose, and then glucose itself can be oxidized. So fructose isn't directly oxidized at carbon 2, but it's converted from a ketose, which is fructose, a ketose, to an aldose, and then the aldose is what is oxidized. So these sugars can also be reduced. So the reduction of a monosaccharide is going to take the C double bond O, the carbonyl group, and it's going to reduce that to a carbon with the hydroxyl group. So when that happens, we have what we refer to as sugar alcohols or aldetols. So again, glucose can be reduced. Normally glucose is a C double bond O with an H, and now we've reduced that double bond O to the hydroxyl group or OH. So glucose gives glucatol, which also has the common name D-sorbitol. So if you look at this particular monosaccharide, this is mannose. Again, it's going to differ from glucose by 1 carbon atom. So glucose, remember, is right, left, right, right. Mannose is left, left, right, right. So at carbon 2, it's going to be different from glucose. But the carbon 1 is going to behave the same way. So if we oxidize our mannose, we're going to change our carbon 1 from the carbonyl group to a carboxyl group. And if we reduce it, we change the carbonyl group to the hydroxyl group. So that's shown on this slide. So oxidation, again, converts carbon 1 from an aldose to a carboxylic acid group. And again, we're going to change the name by changing the ose to onic acid. So D-mannonic acid. And again, for reduction, we take the we take the carboxyl group here, the C double bond O, and reduce that to a COH. So we're going to have an extra hydrogen on here, and we're going to break one of these bonds for that extra hydrogen, and then the remaining bond to our oxygen will stay, and then that oxygen will gain a covalent bond with hydrogen to form the hydroxyl group. So the reduction of mannose is going to result in mannitol. So again, we change the OSE suffix to itol for the reduced sugar. So this is going to be the kind of thing you'll have to do on problem 1552 on page 570. So go ahead and take a few minutes to do that problem before you move on to the next mini lecture.